Integration made simple. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll actually integrate sine to the power of 4x divided by cos to the power of 8x. In the playlist, you must have seen many videos based on integration with trigonometric functions. Well, this is a level 2 question, and we discussed already level 1 questions. I hope you are watching our series with just few examples we can be at a level of level 2 and easily solve such questions. So let me discuss with you strategy to solve the problem before we get into its own solution. Well, the strategy is to convert to tangents and secant. Surprised, right? We are given sine and cosine. Converting to tangent and secant in this particular case, how does it make sense? Let's think about it. Okay, so you see the powers are 4 and 8, very high powers. So in this case, if I write this as integral of sine to the power of 4x over and split cos 8x as cos to the power of 4x times cos to the power of 4x dx, what do you get? Well, the first portion is tan to the power of 4x, and then we have secant to the power of 4x dx. Makes sense. So you see, it is actually the product of tangent and secant with the powers of 2. Now that can make things very simple for us since we know something that if I use one of the function u as equal to tan to the power of, just say, tan x, in that case, what is du dx? Well, du ds is secant square x, right? So you see the other function, secant square x. However, we have secant to the power of 4, not just square. So how do we deal with this situation? Well, clearly, let us rewrite this expression as equal to, let me rewrite this as integral of tan to the power of 4x and secant square x times secant square x dx. Does that make sense? So we kind of are relating and understanding why do we do such a substitution. Well, clearly, now I could simplify further, writing this as tan to the power of 4x and secant square x is 1 plus tan square x, correct? Now it makes much more sense, right? Perfect. Now, clearly, as you can see, we have du, which is secant square x dx, right? So that means we could substitute this with du, that is this portion as far as tan is concerned. We have already substituted as u, and therefore we can easily integrate the expression. So I hope you understand the technique. Perfect. Well, we'll solve it, but before that, let me thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. And these days, we are looking for some of you to contribute. We have been providing absolutely free services for last 15 years, good quality videos which are being watched worldwide, more than 80 countries. Your support matters. You can make a change. You can make millions watch our videos who do not have access to good education. Perfect. So let's get back to the solution of this particular video. So what we have just come up with is that the expression can be written as product of tan to the power of 4x times 1 plus tan square x times secant square x, right? Great. So let us continue forward from here. So what we have here is that we wrote our expression sine to the power of 4x over cos to the power of 8x as tan to the power of 4x, right? And then 1 over sine square x secant square x was written as 1 plus tan square x, left with secant square x dx. Perfect. Substitution, which we are going to make, is u equals to tan x. So du equals to secant square x dx. Now we could rewrite as u to the power of 4 times 1 plus u square times du, right? So that is what we need to figure out. So the integral is, well, you can multiply this, right? So let me just change the ink here. So u to the power of 4 plus u to the power of 6, right? Du. Perfect. So the integral is 1/5 of u to the power of 5 plus 1 over 7 of u to the power of 7 plus a constant c. Substituting tan x for u, we get 1/5 of tan to the power of 5 x plus 1 over 7 tan to the power of 7x plus c. Do you see how we simplified it and wrote down the answer? So it is sometimes very important to think beyond the box, and that helps. I hope it makes sense. Feel free to write or comment, share reviews, and if you like and subscribe to my videos, that'll be great. You can also learn directly by sending an email, globalmathinstitute at gmail.com. We can be part of your success story. Thanks for your time and all the best.